Okay, so my seminar presentation is about designing the race harness for the car, and this is basically the typical process of what we'd be doing in a regular season in the shop. So there's essentially a few steps that we follow in the race harness design process. The first one is knowing what is wanted and required. The second one is determining the best design and best practices just in general, and then we actually get to designing the actual harness. So let's move on to the first step, knowing what is wanted and what is required. And this is basically just gathering up all the information we needed before, and so we can make informed decisions. We start off this usually in the September, October, where each of the subsections will either request a sensor or a specific data type that they want to help with their calculations basically in future years. So essentially, as an example, let's say brakes wants to know the temperature and how hot the rotors get after a certain amount of time. They will give us a certain amount of parameters that we can use to either they go find the sensor that would either hit all those parameters, or we can find it based on what is given to us. After we get all that information, we can actually make the informed decision about which sensor would be best, not just whatever one is going to give us like the best performance, but also we have to look into other factors such as cost and just like how long it will take to get there, because most of them are from the States, so we have to include shipping in that and how long that's going to take. Once we know kind of what the sensors are and like the outputs we want, we have to look into which ones are going to be over which network essentially. So how is the data being transmitted in the harness? Is it going to be an analog signal, which is basically just a one wire straight from the sensor to the ECU as soon as the device's basically measurements are recorded and sent to the ECU? Or we have what is also called the CAN bus system, so the control area network. Essentially, it's two wires, CAN high and CAN low, going to the device, and they work off of a communication system where basically whichever one has the higher voltage peak, so there's a voltage difference between the two, whichever one has the higher voltage peak will have a priority to the ECU to send that data first, then whichever one has the next highest priority in the CAN bus system. CAN bus is usually preferred in automotive, but it does have like a saturation point. It is 1 megabyte, so it is a lot to get there, but we don't want to pile everything on the CAN and risk like getting to that saturation point, especially when you have an ECU with a lot of analog channel inputs and outputs, so it's fine to feed that data directly there through those signals. Most of the sensors that do go on CAN majority are temperature related sensors, just because that's how the gradient works between them. It's easier to put them on the CAN system, and pressure as well sometimes. So basic things to consider, I kind of mentioned this earlier, but knowing what's going to be put on what network. So either like you're putting it on an analog or you're putting it on the CAN for the sensors. And this was more so a problem with our previous ECU because we only had 8 analog channels for those sensors. So we would sometimes even have to sacrifice like which data we didn't think we'd need or wouldn't be as relevant in future years to put more sensors on one, or essentially we are like oversaturating the CAN bus network. But because we have the new Motec M150 ECU, we have, I think it's almost 16 analog channels. So that's basically double than what we had last year. So we can basically put as much sensors as our heart's content on it without oversaturating the CAN network and without sacrificing data. You also have to figure out device location, because certain sensors are going to be more finicky on where exactly you place them in order to measure certain aspects. Like I'll use the temperature sensor as an example again for brakes. Let's say they want to get a variable range of how hot that brake is getting, let's say in like endurance or something. Do we want to place the sensor basically essentially right up against that rotor so it will get that temperature? Do we want it far away so we get more of a range of the entire rotor, not just a part of it? Or do we want like somewhere in the middle, like a sweet spot? So those are things we always have to consider. All right, now we move on to the next step, which is determining the best design or the best practices. So in this stage, we're kind of starting to think about like the actual design of the harness, and more so with, like I said earlier, the kind of the mixed up with placing where everything is going, but as well as figuring out like where the connections are going to and from. So like from let's say the right wheel all the way up to the dash or off to the side of the frame through the firewall and stuff like that, basically. So this leads into the first major diagram, which is the interconnect diagram, which I will show later in the slides. And this is the basically top view of the entire harness. It has every device and sensor that is used. It shows the firewall layout and all the wires going to and from. And basically, this diagram should be able to be read by anyone, not just people on the electrical subsection, to get an overview of the entire system. And if they did want to help, they would at least know that, oh, so if we want to connect a wheel speed sensor in the back rear, it needs power and ground along this line here going through the firewall, and it's going to this input into the ECU, essentially like that. And usually this diagram is blown up to basically poster size so that everyone can read it fine, because usually the text on the ECU is a little bit smaller, but still a reasonable size. Everyone can read when it's blown up to a bigger size. And all of the lines on that diagram should not be crisscrossing to avoid confusion, looped over. I'll show it more in the interconnect. But it also should have like legends describing the different wire gauge and color so that everyone can, or just people who want to help out with the diagrams can see like, oh, you need a 12-volt supply here, so that will be this gauge and this color. I can help you with that. Even before going directly to the interconnect, a simple like even sketch diagram could work just for general placement of the car. So kind of in the picture on the right here. Looking at it, it has different sensors laid out. It has the DAC, it has their ECU. And this one is even nicer as well because it has little color input saying like the red is the detachable and blue is devices that are going to be in a permanent position. And that's kind of even what we have. We have what's called modular diagrams, which I'll get into a little bit later. But essentially, with the detachable modular stuff, it means you can be taking out of the car but not sacrificing performance or some other part of the harness. So that's actually kind of a good representation of what we would have on the car. And usually block diagrams are even good just to start off with. And if you're kind of new to the electrical subsection or just new to looking at this kind of stuff in general, you kind of just like draw out a block here, and then you can like even draw like the wire connections going from point A to B. So it's a good way to just to start and like get your knowledge base going. Now we actually get to the step of designing the harness. So we've gotten all the sensor data, we've got the ones that we want anyway. We know which sensors we want, and we kind of know where they're going on the car based on our little mock sketches and diagrams. So now we can actually get to the actual part of making both the interconnect and the rapid harness diagrams. Before I get into those though, there are a bunch of softwares out there that teams use. Like some people even use SolidWorks Electrical, which actually routes the entire like harness design you make through the car. It's a lot more complicated just because like we haven't done this in the past, so it would be a bit of a learning curve. But it'd definitely be beneficial later in the years, especially since we do design the entire car in SolidWorks. So having that, basically that option to route it entirely into the car, get those lengths right off the bat, not having to wait for the frame to be built to measure everything, might save us some time later down the road. And then some of the other softwares people use are mostly AutoCAD or CATIA, but mainly for the interconnect because there's not many changes per year. Like maybe there's a connection changing, or like this year we have the ECU is changing. We usually just Photoshop to change everything. Not always the greatest, just because not many people have Photoshop on their laptops, but it's not usually big changes that you could even just put it into some kind of editor or Paint even and just like do a quick change here, but there are other ways around that. So this is last year's, technically, interconnect diagram with everything, as you can see, devices, batteries, switches, all the different sensors, relays, fuses, buttons, ECU, DAC, everything that would be on the car. And you can definitely see from the different connections, as I kind of mentioned, like there's no crisscrossing wires. If a wire is going over something, it will loop over to demonstrate that it's not connected to that wire. It's just, in the diagram purposes, it's going over it to get to its actual destination. It's just going over it. It's not merging. If it was merging, it would have like this little dot here, which would be a node or a splice in real life, which I will kind of show off into the later diagrams. You can see everything going through the firewall, which is basically where the headrest is of the car. going through to the other side and to the rear. And it has a legend here displaying all the different colors and schematics and making it easier with notes and everything so that if someone, as I mentioned, who's not mostly familiar with this kind of stuff would be able to tell, oh, okay, so that's kind of what this means essentially. And as I kind of mentioned earlier with the module diagrams, so we try to keep the harness modular, meaning that if something happens per se, let's say a competition, something happened with one of the sensors, it broke or something happened, and having it on there is more of a danger when driving than not having it on there. So because it's a modular diagram, we actually have it so that we can just clip using one of the Deutsch connectors, clip it off from the original harness, take it off, and we don't need to use it. It's gone, it's not going to be a hazard for anything, we don't need the data, but we can easily take it out or even replace it with another extra module if we wanted to. Currently, we have 7 modular diagrams, being like the different sensors that can be clipped on and clip off whenever they want to, the dash system, power distribution, the main front and rear, and then just a basic power one, as well as like steering with all the different paddle shifting in the actual wheel itself. So these modular diagrams make it a lot easier, not just in the manufacturing phase, but in case of emergencies or the case like we don't want to run certain data setups, so we can just take that out there and switch it with whatever setup we want. And as I kind of shown here, as I mentioned earlier with the splices, with the nodes, so essentially what the splices are used, instead of soldering a bunch of the wires together, using splices are easier to just connect 2 wires into one or vice versa, and getting certain power ranges. These are mostly used for power and ground, just because there's so many different devices on the car. You'll have one power going into that splice and then 2 branching off 2 separate devices. So having those splices and not overloading them is important. Alrighty, so now I will just do a little brief rapid harness demo just so you can kind of see what we include into the software and like what we can get out of them and how complex these diagrams can really get. Alrighty, so this is the rear diagram from a year ago. We're currently working on new ones now. But this is the rear. Essentially, it's our most sophisticated one just because of all the engine sensors and the battery. Most of the power is back here as well. So it's the most complicated just because it has more of the devices. We have the large firewall connector right here. This is for power, and this is for anything like additional R sensors and analog and CAN. So essentially, everything that's connected to here will go to an additional diagram, which is the front, so another one. But you can clearly tell that if someone was reading these, oh, so that's the connector that they need to start this harness module, and these are all the different connections going to and from it, essentially. So the first cavity, which is all these different pinouts here, you can't really see it in this picture, but each of these are a labeled pin. So like cavity 1, 2, 3, 4, and all around here, essentially. So cavity 1 is going to this device, X147.1, which is a device labeled in our connector database. And it has a length of just a bit over 40 centimeters. It's an 18 gauge red wire. So if we really wanted to, we could follow that wire along here to the certain device. Even if I look here, it has all the different wires, all the different gauges. And if I look just at the different connections, I can even search up where exactly that connection is. So if I look up the device 147.1, here we go. So if I click this, now you can see it's highlighted red. And if I zoom out a bit, I can see exactly where that connection is going. So it's going from the firewall and to this device here. I believe that's the fan. Yes, it is to the fan connector. So that's how I could easily tell where that connection is going. And this little line here, which is basically to all the engine sensors. These little green things are the splices I mentioned. So just making sure that we don't overload everything. It will be 1 wire going in and then 2 going out to separate devices, or even to another splice even. A lot of these are along the row are in a daisy chain circuit, it's called, And it's the best circuit to allow the current to flow easily along the devices and you don't lose any power. So that is the rear. You can see how it gets a little complicated. I'll show another example of the front here. It's a little less cluttered just because it's less devices, but this one definitely shows the modularity between all the different submodules. So this is actually two different connectors going to the dash harness and another one going to the steering wheel. So in real life, there would be like 3 connectors ending this harness module essentially. 2 would be going to the dash module and 1 would be going to the steering wheel. There would also be an additional one going to the sensors at the front side. So any of the front left or right tires that need sensors on that side, or even our brakes at the front. So anything to do with that. And then if I look over here, this one is going off to the power distribution side of things. So that certain module. And then our ECU. So it shows not only the device, but all the connectors and pinouts, and as well as our wiring table. So the front diagram itself is actually going off to 5 different harness modules: the rear, the dash, steering, front sensors, and the power distribution. So you can see how it can get a little bit complicated with the different modules, but it becomes a lot easier, especially if you need to take something out or put something new in, essentially. And just with the software allows us to have a complete bill of materials. So in case we need a new connector or even just more wire, we have the exact designation for it. We know who's the manufacturers, and sometimes it even has in our wiring table for sure, it has the designation or the product number. So you can just easily look it up and order it. And we also have a wiring table, which will have obviously where it's to and from, color, conductor, engage, and usually the length table will be filled out. So even if someone's just not too busy and they wanted to help out, they could just go off to our wire spools and just cut all the bunch of wire we need, which would help a lot actually. That's kind of seen with the cut list here too. And yeah, that is basically the harness designing process. If you are interested in Rapid Harness more, I have put more tutorials on the OneDrive. And if you have any questions, let me know. Thanks for watching.